Back to our discussion. So the graphene follicle, we have discussed. The secondary follicle will transform into graphene follicle. That means when the secondary oocyte is formed just before the ovulation. What are the chief features? Here, the granular cell they undergo four. So that means on the whole undergo four sub themes like corona radiata, membrana granulosa, cumulus oophorus, periantrum. That means the distinguishing feature of graphene follicle is development of antrum. Antrum. This is very important. Antrum adjacent to adjacent to oocyte. This antrum, then surrounding the antrum will be periantrum. The most important which we have discussed, corona radiata. Corona like crown surrounding the zona pellucida. Membrana granulosa. Here granular cell, that means multi-layers we have discussed now in growth follicle, that means in secondary follicle there are around 9 layers, and they transfer, that means inside to the basal lamina, and they convert into membrana granulosa. And the connecting the membrana granulosa and the corona radiata, there are cumulus oophorus cells or distus proligerus. This is very important. This cumulus oophorus connects the corona radiata with that of membrana granulosa. Then outside that means outside the topmost layer of the granular cells means basal lamina. Outside the thecal cells, theca externa and theca interna. How they form based on cytodifferentiation. Between theca interna and theca externa there are intricate blood vessels. So it's about the graphene follicle structure. The first one, the secondary oocyte, the zona pellucida, the corona radiata, the cumulus oophorus, the membrana granulosa, the periantrum actually, then the basal lamina, theca interna, intricate blood vessels, and theca externa. Starting from inside to outside. It's different layers and structures associated with graphene follicle. Now what we have discussed, the secondary oocyte, when it was ready, that means for ovulation, it will rupture of, just like here, rupture and fall into the fallopian tube for waiting for the fertilization, waiting for the sperm. What we call one oocyte per one menstrual cycle. Just like so on the whole 500 oocytes in a lifetime, though there are 2 million oocytes are there. So it's about the graphene follicle structure. And most important is hormonal influence. Both Oogenesis and Folliculogenesis are coming under the influence of hormones. Totally 5 hormones are reported to influence. One, GnRH, gonadotropin releasing hormone. Number 2, follicle stimulating hormone. Number 3, luteinizing hormone. Number 4, estrogen. Number 5, progesterone. Here the thing is gonadotropin releasing hormone. We knew that hypothalamus releases the GnRH. That means gonadotropin releasing hormone, and will influence the stimulate the anterior pituitary. So as to release the gonadotropin, that means follicle stimulating hormone, and the luteotropin and the luteinizing hormone. LH, luteinizing hormone, or interstitial cell stimulating hormone, ICSH. But actually the thing is FSH, the follicles we have discussed, not all follicles coming under the stimulation of FSH and LH. Here only the antral follicles will means though the primary follicle contain receptors for FSH, but they are independent of gonadotropins. Only the antral follicle comes under the influence of gonadotropins. This is most important feature. Okay. Then regarding estrogen, thecal cells. Actually the thecal cells contain androgen hormone. This androgen hormone will be aromatized. That means just like structural changes, changing the aromatic structure. That means changing the organic structure so that it becomes estrogen. Who perform that? Granulosa cells. The granulosa cells convert that means aromatization of androgen, so that the aromatization leads to estrogen hormone. And the estrogen hormone have a positive. That means here the hormone influence is like positive and negative feedback. This estrogen hormone positively stimulate the FSH and LH. That means gonadotropins. So that the FSH they both have a stimulating effect on the antral follicles. LH is very important. Luteinizing hormone. Now we have discussed ovulation. To perform or for successful ovulation, that means for egg release, say second oocyte release, there should be a spike, higher luteinizing hormone level. Who performs this? Estrogen. Positive feedback, higher the estrogen from thecal cells, then aromatization, estrogen, then luteinizing hormone spike, then ovulation. If something happens here, what we call hormonal imbalance, there will be no ovulation. One of the most important menstrual problem faced by the ladies is hormonal imbalance. There should be a proper luteinizing hormone level. Until there is a appropriate spike reaches, we cannot expect ovulation. No ovulation means no egg. That means no second oocyte that is ready. That means waiting for the sperm. that is most important problem, what we call infertility problems, is because hormonal imbalance. Even diet, stress also have the important role. So if proper hormonal maintenance along the menstrual cycle is essential. And this ovulation, when it's done, if you rupture, the second is come out, and this graphene follicle, the ruptured follicles, they undergo what we call stereoidogenic cluster, dramatic transformation into corpus luteum. Corpus luteum. This corpus luteum is a terrific, is a classical example for temporary endocrine gland. Means they release progesterone hormone. If the second oocyte waiting for the sperm in the fallopian tube has been fertilized, then it has to maintain that means to make sure for the pregnancy. That means the endometrium of the uterus has to get ready. How? The progesterone hormone will do that. And who will release? The corpus luteum will release the progesterone hormone. Progesterone hormone. And this progesterone hormone release maintain the endometrium. If in case if there is no fertilization, the corpus luteum will convert into corpus albicans. Corpus albicans. In the way of white discharge, it will be released out. This is very important. Okay, this is what we call regular discharge phenomenon associated with menstrual cycle. Okay, in the form of corpus albicans. Much specifically. Okay. Then another important thing is inhibin hormone. Inhibin hormone. Actually, inhibin hormone this is also very important. This is also released by corpus luteum. The thing is, just like Sertoli cells we have discussed in previous classes, release inhibin, which inhibits inhibin. That means the word by inhibition. To whom it will inhibit? The FSH, formation stimulating hormone. Here also, there the Sertoli cells in spermatogenesis. Here corpus luteum will perform that. What we call negative feedback. Here, until graphene follicle, the estrogen will be high. When the graphene follicle rupture, there will be no estrogen hormone. So, reducing the level of FSH and LH. That's how that's how hormonal fluctuations, healthy hormonal fluctuations, will be maintained during menstrual cycle. At some point in time, if LH luteinizing hormone will be high, what we call a spike of LH, ovulation, then graphene follicle ruptures and reducing the level of LH and FSH. If better successful fertilization, then progesterone hormone will rise, maintained for the endometrium. This is how the hormonal fluctuations plays an important. This is healthy, what we call healthy hormonal fluctuation is very essential with respect to that means through menstrual cycle. This is very important. And inhibin, now we are discussing negative feedback mechanism. This inhibin will be releasing from the corpus luteum, inhibits the FSH hormone. So that's how the total hormone influence plays an important role in oogenesis and the folliculogenesis. We already discussed. Unlike the spermatogenesis, oogenesis is a difficult phenomenon. The primary oocyte, which has been arrested at prophase 1 of meiosis 1, maintained that means from birth to until puberty. The phase is called, up till this phase is called dictate. Then it will continue meiosis 1, become secondary oocyte, again stop at metaphase 2 and waiting for sperm penetration. So that sperm penetration is important. So that we will discuss in fertilization aspect how the sperm penetration instigates the meiosis 2 so that leads to egg formation. That means ultimately what ovum. Okay, it's about the first oogenesis and the folliculogenesis. The essential difference between the spermatogenesis and oogenesis is the number. I have discussed already. 1.5 million sperms per minute in case of spermatogenesis, just one egg per menstrual cycle in case of oogenesis. And also it correlates with folliculogenesis as well in an integrated way. Okay, thanks for watching.